Hey there, and welcome. We're going to tackle exponential models today. Now, that might sound kind of complicated, but trust me, it really just boils down to two super simple ideas. Once you get these, you'll unlock a huge part of algebra. So let's just dive right in. So you might be looking at this and wondering, how do we get from one tiny little thing to, well, this? I mean, this kind of explosive growth looks chaotic, right? But it's not. It's actually super orderly. And believe it or not, the entire story is written with just two key numbers. Okay, so here's our game plan for the next few minutes. First, we'll look at the two key ingredients. Then, we'll break down what each one actually is, the starting point, A, and the change factor, B. After that, we'll see how to go from a simple story to a full-blown equation. We'll also tackle a super common mistake people make, and finally, it's your turn to try. It's a really clear path to nailing this. All right, part one, let's get into it. I want you to think about this like you're baking something. You know, no matter how wild the final cake looks, the recipe itself is usually surprisingly simple. And that's it. No, seriously, that's the whole thing. Every single one of these exponential graphs, every equation, every word problem you'll ever see, it's all just a story about a starting amount and a change factor. That's it. Once you know how to spot those two things, you've pretty much cracked the entire code. Okay, so let's meet our first ingredient. We call it the initial value, and in our equations, you'll see it as the letter A. And honestly, it is exactly what it sounds like. The initial value is just that, your starting point. It's the amount you have before anything starts to grow or shrink. On a graph, this is always the y-intercept. You know, it's that spot where the story kicks off, right at time 0. And check this out. This graph shows it perfectly. We're looking at some bacteria on a desk, right? The bottom axis, the x-axis, is time. So look at time 0. Where does that curve hit the y-axis? Bam, right there at 100. That's our initial value. That's our A. We started with 100 bacteria. Simple as that. All right, time for ingredient number 2. This one is the real engine of the whole thing. It's what makes the change happen. We call it the constant multiplier, or B. So, the constant multiplier is the number that does all the heavy lifting. It's the factor you multiply by over and over and over again to get that classic swooping curve. And the most important thing to remember here is the word multiply. We are always multiplying, never adding or subtracting. That's key. Now, what's really cool is that the value of B tells you the entire plot of the story. If B is bigger than 1, you've got growth. Things are getting bigger, going up. But if B is a number between 0 and 1, like a fraction or a decimal, you've got decay. Things are getting smaller. So that one little number tells you the whole direction of the story. Are we growing or are we shrinking? Okay, so we've met our two key players, A and B. Now for the really fun part. Let's take a real-world story and use these ingredients to cook up the actual exponential equation. It's a super simple 4-step process. Step 1, find your starting amount. That's your A. Step 2, find the percent change in the story. Step 3, and this is the most important step, use that percentage to figure out your multiplier, B. And then finally, step 4, you just plug A and B into that standard formula, y equals A times B to the power of x. Okay, let's work through an example. Say we've got a spray that kills 70% of 100 microbes every single minute. So first things first, what's our starting amount? What's our A? Well, the problem tells us we started with 100 microbes, so that's easy. A equals 100. Okay, now for the part that sometimes trips people up. The spray kills 70%, but remember, our multiplier, B, isn't about what's gone. It's about what's left over for the next minute. So I'll ask you this. If 70% of the microbes are killed, what percentage remains? Exactly. If you get rid of 70%, you still have 30% left. And to use that number in an equation, we just have to write it as a decimal, which is 0.3. And that is our constant multiplier. That's our B. That's the number we're going to multiply by every single minute. And just like that, we can build the whole equation. We take our initial value A, which was 100. We take our constant multiplier, B, which we figured out was 0.3. We just slot them right into the formula, and boom, our function is f of x equals 100 times 0.3 to the power of x. We just took a word problem and turned it into a powerful math model. Okay, before we go any further, I want to quickly talk about one of the most common ways people get mixed up when they're first learning this stuff. It's a really simple mistake, but it's super important to get it straight. Here's the deal. Exponential change is all about multiplying. You are multiplying by the same factor over and over again. Now, you probably remember linear change, right? That's all about adding or subtracting. You're just adding the same amount each time. So think of it this way. If your allowance goes up by $5 every week, that's linear. But if your allowance goes up by 5% every week, that's exponential. It really all comes down to, are we multiplying or are we adding? All right, you've seen the pieces, you've seen how they fit together. Now it's your turn. Let's see if you can be the detective and find our two key ingredients in a brand new story. So here's the scenario. Marshall buys a car for $25,000. Every year its value depreciates, which is just a fancy way of saying it goes down, by 10%. So your job is to figure out two things. What's the initial value, A, and what's the constant multiplier, B? I'll give you a second to think about it. Okay, let's break it down. We'll start with the easy one, the initial value. What was the car's starting price? Well, right at the very beginning, at time 0, he paid $25,000. So our A is $25,000. All right, now for the multiplier. This is the tricky one. The car loses 10% of its value each year. So the question is, what percentage of its value is still there at the end of the year? Well, if you start with 100% and you lose 10%, you're left with 90%. And as a decimal, that's 0.90. So our constant multiplier, our B, is 0.90. And that's really it. The starting point and the change factor, the initial value and the constant multiplier. Once you get comfortable spotting these two ingredients, you really hold the keys to understanding the entire powerful world of exponential functions. I mean, think about it. From how your money could grow in a bank account to how medicine fades in their body, what other stories are all around you that are really just a tale of these two simple numbers?